Guys, welcome back to another video. So in this one we'll be doing a complete walkthrough as always of the Edexcel IGCSE paper, and this time we'll be looking at the January 2019 Maths A paper 2H. Okay, so I'm going to go ahead and skip straight to the question. Okay, question 1. So a plane has a length of 73 meters. Now the scale of the model is made of the plane, and the scale of this model is 1 unit to 200 units. So what this means, that in reality the plane itself is 73 meters, but if you had to jot this down on paper, you need to divide it by 200 to find its actual scale. So we can say, alright, so on paper it's going to be 73 over 200. Okay, and then doing that, 73 over 200, and always do this in calculator, guys, you get 0.365 meters. Okay, so that's the length on the paper right now. Now work out the length of the scale of the model. We did that. Give your answer in centimeters. So we ain't done that. So to go from meters to centimeters, you must always multiply by 100. So just times this answer by 100. And doing that, you should get 36.5 centimeters. And that's it, guys. That's literally one done. Alright, number 2. So here are the first 5 terms of an arithmetic sequence. Okay, so you got 7, 11, 50, and so on. So we can see they're going up in 4s, so plus 4. Write down an expression in terms of n of the nth term of the sequence. Now the nth term formula is very straightforward. I mean, you could memorize it by one or two methods. I'm going to use the formula method. So the formula is always this. It's always the first term, a, plus n minus 1 times d. Okay, d being the difference. Okay, so looking at each ring, so we can see that the first term a is 7, so it'll be 7 here, and we can see it's going up in plus 4, so it'll be plus, so it'll be all of this lot, n minus 1 times 4. So timesing this by 4, you're going to get 4n minus 4. And just tidying up now, collecting like terms, so you're going to have 7 minus 4 is 3, so it'll be 3 plus 4n. That's it, guys, all you have to do. Okay, number 3. So there are 90 counters in a bag. All right, each counter in the bag is either red or blue. We'll keep that in mind, so that the number of red counters to the number of blue counters to 13. Let's go ahead and work out how many counters we have straight away. So if you want to change this one into some sort of fraction, we can see that out of the total number of counters, let's say 15 parts, if you add them up, we can say that 2 out of 15 is red, and therefore 13 out of 15 must be blue. Now if you want to straight away work out how many counters there is, you literally just put in the calculator 2 over 15 times 90. And doing that, 2 over 15 multiplied by 90 will give us 12. So there are 12 red counters. For blue, same thing, 13 over 15 times 90. And that's going to give us 78. And of course, just double checking, adding these two, you get 90. So it checks out. Now let's keep going. So Lee is going to put some more red counters in the bag, so that the probability of taking at random a red counter from the bag is 1/3. Okay, so let's think about it a second, yeah? So you have 90 in total. He's going to add some extra red counters, yeah? And you got 12 reds already. So it's going to be 12 plus some extra counters, let's say x. That means you now have 90 plus x in the bag, right? So this is going to be red counters, and this is going to be, and blue counters, well, is still 78. And here's the total. Okay, now it says here that the probability of taking at random a red counter from the bag is 1/3. So this means that the probability of taking a red, and you know how many reds there are, you have 12 plus x over 90 plus x, and it's going to equal 1/3. Okay, work out the number of red counters that Lee is going to put in the bag. Now literally you just have to solve this algebraic equation. The easiest way to solve this nicely is to literally multiply 90 plus x across and 3 across. So timesing 3 across and 90 plus x across, you can have 3 on the left side multiplied against 12 plus x. You can have 90 plus x on the right side multiplied by 1, which is, well, 90 plus x. So let's go, and then expanding both sides, 3 times the bracket, you can get 36 plus 3x. The right side, 90 plus x. Now the tip is to always move all the x's on the left and all the non-x terms on the right. So moving plus x across, you're going to minus x. So 3x minus x is 2x. Moving plus 36 across, it becomes minus 36. So subtract 90 from 36, you're going to get 54. And finally, to get x, you got half it. So half of 54 is 27. So this means they added an extra 27 reds. So now it says, work out the number of red counters that Lee is going to put in the bag. He's going to put an extra 27 reds. Alright, number 4. So according to this system, so this here tells you all the numbers are actually allowed in the square inside the Venn. And it tells us that all these 12 digits from 1 to 12 are the only possible numbers in this universe of sets. Now set A tells you out of these set of numbers, we only choose the odd values. So numbers like 1, 3, 5, 7, 9, and 11 are allowed. So it's probably best we write it down. Okay, so always write down the actual number versions, yeah? Okay, perfect. You can use the curly brackets. Now it tells us here the next part, A and B. This means that when the set of A intersects with the set of B, only 1 and 3 are in common. So from this information, we can say that set B must have at least 1 and 3, because that's what they have in common. Now the next part, AUB. This means that A unites with B, and this means that when you collect A and B, these are all the numbers that they have. So what you can do is look at all the other numbers that don't exist in A but are united with A and B. So we can see that A has odd numbers, but B here has, let's see, like 2, 4, 6, and 12. So that's all the possible options we have in B. Okay. Now what you want to do here is now you want to sketch a Venn diagram. Okay. So because we're dealing with A and B, we just draw 2 circles. So you got A, and you can call this one B. So A and B. So it doesn't have to look pretty, you just have to make sure it's within the box. Now inside of A, let's put what they both have. Let's put the center bit. The center bit is what they both have in common. We know they both have a 1 and 3. So you put 1 and 3. Now we look at just A, what A has. A is all odd numbers. So we've already included 1 and 3. We also put 5, 7, 9, and 11. So 5, 7, 9, 11. As for B, we've covered 1 and 3, but it also has some even numbers. So it has 2, 4, 6, and 12. Now we're not done yet. Now we're going to put the numbers that we did not include A, B inside, just outside the circles within the box. Because remember, this universal set is kind of epsilon looking thing, has 12 digits. So what do we not include? So we covered the 1, we covered the 2, so 1, 2, 3, 4, 5, 6, 7. There's no 8, so 8 goes outside. 9, there's no 10, 11, 12. And that's it, it checks out. So that's really what you do for Venn. You just want to see what numbers they have and literally just draw a nice sketch. Alright, number 5. So Calvin has 12 identical rectangle tiles. He arranges the tiles to fit exactly around the edge of a shaded rectangle. So he's talking about, so these 12 identical tiles are literally all of these around, yeah? Now, as shown in the diagram below. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, just double checking. So, yeah, so work out the shaded area. Okay, so they all have, so we go look at this way, yeah? So they all have the same length. So let's suppose this length, we don't know what it is. Let's just call it X, yeah? So we got X, 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 and so on, yeah? It's always good to just label them all, just to make it easy. Now this extra little shortened bit, let's call it Y, yeah? Let's give it another letter. Y, 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 and so forth, yeah? So now we can say, and because we've got actual measurements, we can say, alright, we can say that the width of this would be 123 equivalent to X plus X plus X plus X plus Y. So you can see that a total of 4 x's plus y must be 123. Looking at the vertical, we've got x plus y gives us 67. So that's 2 x's plus y equals 67. Now we have literally a pair of simultaneous equations. If we can work out what this is, then we can literally figure out what the shaded area is. We'll get to that in a second actually. So the easy way to do this, you can look at both equations. Thankfully, we have y's which look the same. We could just subtract this entire equation. So if you do that, you're going to have 4x take away 2x, which is 2x. Y take away y, which is nothing. And you got 123 minus 67. So in your calculator, you can do that, and you get 56. And then to get x, you got half this. So half of 56 will be 28. So now we got something. And again, if you want to find y, just pick an equation like this one for instance and make y the subject. So to do that, subtract 2x across. You can have y equals 67 minus 2x. So plug in the value of 28 for x. So you're going to have 67 minus 2 times x, which is 28. And that'll give you your y. Put this in the calculator. So 67 minus 2 times 28, you get 11. So now we're almost done, yeah? So the point of this is that when you find these lengths, you can kind of chip it off here to work out the actual length here. Okay, we can see that, let's just have a look for a sec. So we can see that if you want to find the height of this one, is going to be all of this x plus this x minus some y. Notice that this little bit is length of y. So we can say, all right, this x is going to be, what's x again? 28. This length is going to be 28 minus the y bit, which is 11. And 28 minus 11 is 17. So that means the total length here, let's put 17. So the total length would be 28 plus 17, and that's 45. So probably best we resketch this actually. Okay guys, so let's see. So it'll be 45 here. This is the shaded area. Now for the width, what do we have? So we got x plus x plus x plus x minus y, yeah? So x, x, x. So we got 4x minus y. Okay, so what's 4x minus y? You got, let's see, 4 times 28 minus 11. That's going to give us 101. Okay, and just checking your measurements are okay. We compare it to the actual lengths. It's smaller than 67. So 45 is smaller. 101 is also smaller than 123. So it could be legit. Feels legit. Now to find the area, it's always just base times height. So 101 times 45, and that should give us 4545. So 4,545. And that's it, guys. All right, here we go. Number 6. So find the highest common factor of 96 and 120. Okay, highest common factor. To do this nicely, let's just break 96 and 120 into prime factors, yeah? So the method usually is to use a Venn diagram when you do this. So breaking this down, you know, from 2's and whatever. So 96 can be broken down to 2 times 40. God, I do not know this one. 48. Is that right? Yep. Breaking down 48, that's just 2 times 24. Breaking this one is 2 times 12. Breaking down 12 is 2 times 6. Breaking down 6 is 2 times 3. And when you do that, make sure you circle all your prime factors. So like 2, 2, 2, 2, 2, and 3. Okay. Now, as for one, so then we can say therefore 96 is going to be, how many 2's we have? 1, 2, 3, 4, 5. So it'll be 2 to the power of 5 times 3. And then we do the same for 120. Okay, so let me just change the color a bit. So 120, and you can do it anyway. I'm going to break this down into 12 times 10. So you got 12 and 10. 12 can be broken down into 2 and 6. And 6 is down into 2 and 3. 10 is the same, or different. It'll be 2 and 5. And then circling, you know, the last legs is going to be 2, 2, 3, 2, 5. So we can see that 120 is the same as, how many 2's we have? 1, 2, 3. So 2 to the power 3 times a single 3 times a single 5. And now, when you got all of this down, you can just draw 2 Venn diagrams, so 2 circles. Label one of the circles 96 and the other one 120. And now, the highest common factor will be what they all have in common. So we can look at all these numbers. We can see that 96 has 2 to the power 5 and 3, and 120 has 2 power 3, and so on. They both have 2's up to 3 powers. But 96 has an extra 2 powers of 2. Okay, as for what else they have? They both have a 3, and a 120 also has a 5. So then the answer would be the middle sect. The middle part is the highest common factor. So the highest common factor is 2 to the power 3 times 3. And that's it, guys. That's literally how you do it. Okay, part B. Find the lowest common multiple of A, B, and C. Now, lowest common multiple is so easy when it comes to powers. you just look at all the numbers and just pick the highest powers of each one. So we say that, okay, the lowest common multiple, so starting with 2, the highest power in all of them is 4, so 2 to the power 4. For the 3's, there's only 1 3, so include that. For 5's, you got 5 and 5 squared, the highest power is 2, so 5 to the power of 2. For 7's is 7 to the power 2. And lastly, 11 is 11. And that's it. So Jenny invests $8,500 for 3 years in a savings account. She gets 2.3% per year compound interest. So this means the money increases every single year by 2.3% compounded every year. So how much will she have at the end of 3 years? Okay, so this is just a straightforward formula, nothing special here. So if you're familiar with this formula, it's always the original value, in this case 8,500, times some multiplier, in this case 1 plus minus the rate, will give us a new value. And if there's years involved or several periods, you put a power here, so in this case 3. Now the original value is going to be 8,500. The rate is going to be an increase of 2.3%. So it'd be 8,500 times 1 plus, because you're increasing, 2.3%. Remember, use the percent button and that'll give us our answer. Alternatively, if you prefer to change it to a decimal, 2.3% is the same as 1 plus 0.023. But I don't know why you would want to do that when you have a calculator, because then you could just make a mistake by converting the decimal. Anyway, when you do this and you power it by 3, you should get 9,100.092 and so on. And they want the answer correct to the nearest dollar. So in other words, the nearest whole number. So that would be about $9,100. Because rounding up this value here, well, it's less than 50 and this is less than 5, ain't gonna round up. Okay, so that's it, 9,100. Now next one. Rami bought a house on the 1st of January 2015. So in 2015, the house increased in value by 15% and the next year decreased in value by 8%. So on the 1st of January 2017, so that's 2 years later by the way, the value of the house was this amount, $687,700. What was the value of the house on the 1st of January? In other words, what was the original value? So we can go back and use this previous formula, but you're probably thinking, like, hold on, this is only for like the same thing for several years. Actually, you can partition this part into several different multipliers. So for instance, because we're dealing with 2 different rates, if we had to rewrite the formula, it will be, for instance, if the house increased by 15%, it would be 1 plus 15% times 1 minus 8%. So this is kind of like, in a way, 2 different years, but with 2 different rates. This power here means it's increased by 1 plus 2.3%, 1 plus 2.3%, and another 1 plus 2.3%. So it kind of makes sense. And this, anyway, should give us a new value, which we're told is $687,700. Now, to make your life super easy, just use some algebra. Literally make OV the subject. So we can say, all right, OV is going to equal, so literally divide this entire double bracket below this value. So it'll be 68700 over all of those lot. Okay. So just checking if it's right. Increase by that, decrease by that. And when you do this, smash in your calculator, guys. And you should get an exact answer of, oh, that's nice, 650,000. Yeah, that makes sense. Dollars. All right, number 8. So a block of wood has a mass of 3.5 kg. The wood has density 0.65 kilograms per meter cube. Okay, before I move on, if you're not sure if you forgot the formula of density, it is a little trick you can do. Just look at the units it's using. It's saying kg per meter cube. So kg, as we know, is mass. So we say density equals mass over, and a meter cubed, well, this is a volume. Okay, it's not a length, it's a volume because it's cubed. And there you go. So this is what they have. So this is the density formula. Now A, work out the volume of the block of wood. Alright, so this is very straightforward. You just want to make V the subject here. So you could just swap V and D around. So you can have V equals M over D. Remember, you multiply V and you divide D. And now we have the figures. We have the mass. Okay, before I jump straight ahead, the mass, so notice how, okay, never mind. So you got the mass, which is 3.5 kg. over the density, which is 0.65, dividing these lot. So 3.5 over 0.65, and to 3 significant figures, you should get about 5.38. Okay, I think that's it. And this is volume, so meter cubed. So you just take the unit which you're not using. Alright, yep, meter cubed. Now next one, change a speed of 630 kilometers per hour to a speed in meters per second. Alright, so let's write down. So 630 kilometers per hour into something meters per second. Not too bad. So first we change 630 kilometers into meters. If you want to do that, you multiply kilometers by 1,000, because there is there is 1,000 meters in 1 kilometer, so it'll be 630,000. Okay, and let's put meters there. Now for 1 hour, so this is literally 1 hour, right? We need to convert 1 hour into seconds. So we need to know that firstly we have 60 minutes in an hour and 60 seconds in a minute. So technically that'll be 60 times 60 seconds, which is 1 hour, by the way, guys. And yeah, that's actually it. So now we just divide these numbers. So it's going to be 630,000 over 60 times 60, and that's 175. Then you write meters per second. Just copy those letters down. Now this is literally one of my favorite questions to do. So 9, solve the simultaneous equations. Alright, so what you want to do here, and this is both linear, by the way, there's no square terms anywhere, is that you want to make the coefficients, in other words the numbers in front of the x or the y, is the same. I'm going to pick x because it's kind of easy to double 2x to get 4x. Okay, so let's do that right now. So what you want to do is double the second equation, and we're gonna discuss as we do it. Yeah, this will give us 4x minus 2y equals 18. So remember, when you times it by 2, you times the whole system by 2. And the first equation, well, it's going to be the same because we're not multiplying that. Okay, now what to do here is that all you really have to worry about now is literally subtract these pair of equations, because the purpose is because you have 2 different variables in the same equation, you cannot solve it. So the idea is to eliminate a variable so you have only 1 letter left, so it's easy to solve. Now since we've got 2 4x's, we can just subtract this equation to eliminate the 4x, right? So let's minus the whole thing. So put red. So subtracting 4x, of course, that's the aim, you get nothing. So we can actually just leave it blank. Then you got 5y minus 2y, so that's a double minus, so it's a plus. So 5y plus 2y is 7y. And then 4 take away 18 is minus 14. Yeah, and then this is easy now. Find y, divide by 7, you get minus 2. Done. Now in order to find x, well, just pick any of these 4 equations. So let's pick let's pick this easy looking one. 2x minus y equals 9. Okay. So what you want to do here now that you got the value of y, we can plug it back in. So this would mean you're going to get 2x, instead of minus y, would be plus 2 equals 9, because y is minus 2. Subtracting 2 across, you get 2x equals 7. And dividing by 2, x equals 7 over 2, or 3.5, if you really care. Alright, number 10. So the line L is drawn on the grid. So here's the straight line. So this is basically an equation which is part of y equals mx plus c, by the way, yeah, with some gradient and some intercept. Find an equation for L. Oh, really? Is that it? Nice. So 2 easy ways to do this, yeah, and literally this is something we just need to know in the back of our mind. You just pick 2 random points on the line. My tip is always pick the intercept because it's nice, and any other point that actually has a whole number like 2 and 4. So let's label these points. So this is of course 0, 1, and this one is 2, 4. Now when you use y equals mx plus c, the c bit is the y-intercept. So you can see it hits the y-intercept at 1. So now immediately our equation becomes mx plus 1. Now to find the gradient, there's a beautiful formula you could do. The gradient formula is this. It's the change in the y-coordinate. So you do, let me write the formula down. So it'll be change in the y over the change in the x. So the triangle means delta, which means change in Greek. Yep. So change in y, so be 4 take away 1 is 3. And 2 take away nothing is 2. And yeah, we've done it. So the gradient's 3 over 2. So y equals 3 over 2x plus 1. Wow. Yeah, that was easy. All right, number 11. So 20 students took a science test and a maths test. Both were marked out 50. And below gives information about the results. So you got the median and the interquartile range. So the median, as a reminder, is pretty much the middle student. So if you had to list up all the marks in order from the lowest mark to the highest mark, the mark bang in the middle represents the median student. So you can see 27 was bang in the middle for science, and maths was slightly lower, bang in the middle, 24.5. The IQR means that you take the first quarter, instead of finding the middle, you find the first quarter of the mark and the third quarter and you subtract it to have a difference of 18. Same applies for maths. So we have to look at if we have to compare these results and make some comparisons, all we can really talk about is firstly give a discussion about the median and give a discussion about the interquartile range, which we're going to call it IQR. Yeah, that's just a shorthand way of saying it. So first things first, let's talk about IQR. Yeah, we can say that the spread of the marks in science was far greater than the spread of maths, because the maths result seems more consistent. So more people, because it's lower here, it means that the difference between the first and third quarter students were closer in marks. So let's say this, we can say that the spread of the marks in science were far greater than maths. So you can put a bracket, IQR of 18 is bigger than IQR of 11. Okay, obviously we shouldn't write like that. Actually, it should be IQ of science bigger than IQ of maths. And we can say that the median mark is 2.5 marks higher than in science than maths. So median mark was higher. Oh wow, oops. Was higher in science than maths by the difference was 2.5 marks. Okay, I think that should be okay. Right, number 12, guys. So simplify n to the power 0. Well, this is easy. Anything to the power 0 is always 1. It's never 0. Okay, be very careful. Yeah, this is not you're not timesing by 0. Any power to nothing means it's like you're dividing by itself, so it's always 1. Okay, now B, simplify 3x squared y power 5 all powered by 3. This just means you give everybody in the power a 3. So be 3 cubed, x gets a 3 next to the 2, and y gets an extra power of a 3. Okay, and simplifying this, well, you can just use a calculator for 3 cubed. That will give us 3 times 3 times 3 is 27. X to the power 2 times 3 is 6. Y to the power 5 times 3 is 15. Easy, yeah? Now, C. Factorize fully 2e squared minus 18. So let's have a look. When I use the word fully, it means it's probably 2 steps. So the first step is to see the any common factors. Well, they're both in the 2 times table. So divide this by 2. You're going to get e squared minus 9. Now, one thing to observe here is that this form here is known as a difference of 2 different squares, as in a square number or square term minus another square. So what we have to do is, this is a double bracket problem. So we firstly square root e squared, you get e on both sides. Square root of 9, you get 3 plus minus 3. And that's it. You've literally fully factorized it like that. Okay, so e plus root e minus 3. Yep, that's it. Now D. Oops. So make R the subject of this equation here. Now, when you have a square root, you clear the square root, yeah? So the opposite of square rooting is squaring. So if you square both sides, you're going to get m squared equals, and of course, the square root now actually disappears because you cancel it. Now, and another thing you want to do is always clear the fraction. So you got 5r at the bottom. Let's multiply by 5r. So timesing m squared by 5r, you get 5 and m squared r, or however you want to write it, equals 6a plus r. Again, the 5r is gone now. Now here's the tricky bit. because you got r's on both sides and they don't look like they're compatible, the trick is to firstly move all the subject terms, in other words the r terms, to one side. So let's move this plus r to the left. So you're going to have something like 5m squared r minus r, because you moved it across, equals 6a. Now the final step, now the key step here is to realize, because you got r's on both sides, you can factorize the r out. So yeah, so factorize the r out, you can be left with 5m squared minus, if there's no more r's left, it's just going to be 1, because r divided by r is 1, equals 6a. And now finally, if you want to isolate the r, because you want to make r the subject, let's divide this big term across. So you're going to have something like r equals 6a divided by that big term, 5m squared minus 1. And that's it, guys. I think we're done. So the frequency table gives information about the numbers of mice in some nests. So on the left hand side, we've got the number of mice, and frequency is just basically how many times these mice occurs. So you can say that for the first column, the number of mice is 5, and this occurs 4 times. So collectively is like 5 times 4, so 20 mice altogether in the first column. And yeah, so on. Now at the bottom, the mean number of mice in a nest is 7. Work out the value of x. Okay, so the best way to do this is to firstly go through the mean procedure. So to calculate the mean, we need to make a new column called fx, where f is the frequency and x is the number of mice. So fx is essentially f times x. So we're going to go ahead and multiply all of these guys, yeah? So let's do that first. So 5 times 4 is 20, and 6 times 13 is 78. The next one is 112. 8 times x, 8x. 9 times 6, 54. And so the mean is going to equal the total fx, so we're going to go ahead and add up all those values we found, over the total frequency. So we need to add up this whole column here. So total frequency. Now the total fx, if you add up all of these terms, you're going to get 264 plus 8x, so 264 plus 8x. And the total frequency, if you add up all of these, you're going to get 39 plus x. And we know that the mean is supposed to equal 7. Okay, now all you guys want to do is literally solve this part of the equation and find the value of x. Okay, so to do that, let's go ahead and multiply 39 plus x across. So we want to clear the fraction. So you're going to have 264 plus 8x equals 7 times 39 plus x, 273 plus 7x. And then finally, just moving all the x terms on the left and the number terms on the right. If we subtract 7x, we're going to get 1x here. Subtract 264, you're going to get 9. So x equals 9. Okay, number 14. So Marcus plays 2 games of tennis. For each game, the probability that he wins is 0.35. Okay, so we know straight off the bat for every single game is 0.35 of winning. So literally write that down here. Now, this means that the probability of him not winning, in other words, losing, will be 0.65. Why? Because all probabilities must add up to 1. Okay, so that means the rest will be 0.65. Yeah, and that's it. That's 2 marks right there. Now B. Work out the probability that Marcus wins at least one of the 2 games of tennis. So if he's going to win at least a game, that means he could either win the first game, then lose the second game, or lose the first game, then win the second game, or, because this is at least, he could win both games, because that's still at least winning a game. So we write down the probability options. So that's win the first game, lose second, lose the first, win the second, or win both games. And then you literally just find the probabilities. So this symbol I'm writing is a nice way of keeping track of what you're doing. So winning then losing, so that's 0.35 times 0.65. So 35 and 65. Losing will be 65 times 35, and winning both times will be 35 times 35. So when you work them all out, you then have to sum them up here. So let's do it. So 0.35 times 0.65, that'll give you 0.2275. So you do that again here, And then last one, 0.35 times itself will be 0.1225. And then that means the total probability, so any of these three options can happen, so you have to add them up. So plus 0.2275 times 2. So that means the total probability of him winning at least game would be 5775. Yeah, and that's it, guys. That's literally done. Okay, number 15. So the diagram shows a trapezium. Okay, so we're actually given the area of the trapezium formula in the front of the booklet. And the formula is something like half times a plus b times the vertical height. Okay, so a and b represents the top parallel lines, so a and b, and this is the vertical height. Okay, so we have all the piece of information here. Now all measurements shown on the diagram are in centimeters. The area of the trapezium is 133 centimeters squared. So this is again the formula of the area. Yeah, show that you can make this quadratic equation. So when they give you something like this, you literally have to pretty much apply what you know from the given information and somehow form an equation and then simplify it, and it will look like this quadratic. So let's use the info. Yeah, so since we have the area of the trapezium formula, we can go straight into it. So replace a with 133. So the area equals half times a plus b, so x plus 5 plus 3x minus 2. So adding them up, the x's become 4x. 5 plus minus 2 becomes plus 3. And then times the height, times 2x minus 3. Okay, so that's a quick way of doing it. Now we just got to simplify all of this. So first thing you want to do is just multiply 2 to get rid of the half. So times this by 2, you get 266 equals all of these. Okay, so now we got to expand this bracket, yeah? So we're going to have 266 equals, so open this quadratic, you can have 4x times 2x, 4x times minus 3, 3 times 2x, and 3 times minus 3. So let's do 4x times 2x, that'll give us 8x squared. 4x and minus 3 gives us minus 12x, this makes plus 6x, and 3 times minus 3 is minus 9. And now you just tidy this up. So let's so you can have 266 equals 8x squared, minus 12x plus 6x is minus 6x, minus 9, and of course you can just look at the answer. If you subtract 266 across, you're going to end up with minus 275. So yeah, we've pretty much proven it. So yeah, just make sure you always write it down, yeah? Okay, good. Now, B. So find the value of x. Alright, so in other words, just solve this quadratic equation. So we're going to use a quadratic formula, yeah? And the quadratic formula is also given in the front of the booklet, which is x equals minus a plus minus square root of b squared minus 4ac over 2a, where a is the first value here, which is a, b is the value of minus 6, and c is the value of minus 275. All right, so let's plug it in. So you're going to have basically minus b end up becoming plus 6, plus minus the square root of, now b squared, so minus 6 squared is literally just positive 36, minus 4 times 8 times minus 275. So a quick note is to always wrap up your values in a bracket, yeah? Over 2 times 8. And then just, let's put this in the formula, yeah? So in your calculator, you can have 6 plus 36. And then you'll get either x equals 6.25 if you use the positive root, or if you put a minus, you're going to get minus 5.5. So only one answer is correct because it says find the value of x, i.e. singular, yeah? And because we're working with lengths, the only reasonable answer would be the positive value because you can't have negative lengths. So it'll be 6.25. That's it, guys. Alright, number 16. So the diagram shows two mathematically similar vases, A and B. Now, this term mathematically similar literally means that we have pretty much identical shapes, except one of them will be proportionally bigger than the other. So we're only concerned about some common scale factor, yeah? So we need to find what the scale factor could be. Okay, so when you determine that, you can literally figure out the length, volume, and area of the next shape. So let's have a look at this example, yeah? So we've got A, the first shape has a volume of 405, and B has a volume of 960. Okay, so before we do anything else, we can relate the volume, yeah? We can say that the scale factor, and because we're working a volume, it will be power 3 equals the ratio of the volume of B over the volume of A. If this was area, which they have next bit, because area is a two-dimensional shape, it will be n to the power 2 equals the area of shape B over the area of shape A. Alright, I can see there's two ways, yeah? So I should actually write surface area of B over surface area of A. Okay, so now all you have to really do is just figure out the scale factor n from the first equation, plug it to find the scale factor to solve the second equation. So let's do it. Okay, so that means using the first set of equation here, we have the volume of B and the volume of A. So therefore n cubed equals 960 over 405, and then literally cube root this answer, and you will get 4 over 3. So this is actually the scale factor. So we can say that this shape is 4/3 bigger than A, volume wise. Now therefore, if you got this scale factor, we can literally figure out the surface area of A, because we have the surface area of B, which is 928. So using what we know, so we can say from the second equation, n squared equals the surface area of B, which is 928, which is here, over the surface area of A. And remember, we know what n squared is. It's 4 over 3 squared. So essentially we're solving this bit. Then all you have to do really is literally solve for SA. So multiplying SA across and dividing 4/3 squared across, you're going to have a surface area of 928 over 4/3 squared. Again, put this in your calculator and you'll get 522. That's it, guys. That's all you do. So f is the function such that fx equals 4 minus 3x. Work out f5. For this one, you literally just replace x with 5, because that's what actually happened. So this means that the function at the point 5 is now 4 minus 3 times 5. And putting this in the calculator, well, this is going to give you minus 11. These kind of marks are easy, yeah? So when you do questions like this, just replace x with what you have. Now, next one, g. G is the function such that gx is 1 over 1 minus 2x. Find the value of x that cannot be included in any domain of g. Again, domain literally means values of x that you're allowed to have. Now, a common rule for these kind of questions is that they could either give you a fraction or a square root function. The rule is that if you're dealing with a fraction, the denominator cannot be 0, because you can't divide any number by 0. So we can say that 1 minus 2x cannot be equal to 0. So that's exactly what the question wants. It wants to find that particular value x that we're not allowed to do. So solving this equation, so we can plus 2x across. You got 1 can't equal 2x. Dividing by 2, which is 1 over 2, can't equal x. So x can't equal half. Okay, that's the value x we're not allowed to have. Now part C. Okay, so work out fg minus 1.5. So what this tells us is that we have to plug g into f. That's what fg means. G goes inside f. So taking this g function, we're going to pop it into f. So when you say pop it in, it literally means replace the x bit of f and put this g inside. So we're going to have fgx equals 4 minus 3 times 1 over 1 minus 2x. And now this is straightforward because it actually gives you a value. It gives you minus 1.5. So now you're going to replace this x with minus 1.5. So our final answer is going to be something like 4 minus 3, 1 over 1 minus 2 times minus 1.5. But then literally just pop this in the calculator. And if you do that, you actually get 3.25. Okay, number 18. So it tells us that we have p equals a over m minus x. And each of those 3 letters have been rounded up to either 1 significant figures, 2 significant figures, or the nearest tens. Now, to have a look at this carefully, that means each of these values was probably some decimal or different values before. So x, for example, has been rounded to 8. So it could have been anywhere between 7.5 up until just before 8.5. For the value of a, it could have been anywhere between, we could say 4.5 4.55 because rounding it up will give you 4.6, or just before 4.65. So again, it all kind of has the same trend. It's always going to be a 5 in the ends, by the way. So for m equals 20, this could have been anywhere between, and let's think about, if you're going to round it to 20, the highest it could have been is before 25 or 15 and above. As always, yeah? Again, 5 on both sides. So now the actual question wants us to calculate the lower bound of p. So the lower bound of p, meaning how could you possibly minimize this result? Well, if you're dividing or subtracting, the best way to minimize the result, if you have a lower bound result and you divide it against an upper bound result. Why? Because the bigger the denominator and the smaller the numerator, the smaller your final answer will be. So in other words, we need to find a lower bound for a. So the lower bound for a is clearly this value here. However, on the denominator, we need to find an upper bound. And again, because you're subtracting, to get the biggest bound, you need to have the greatest distance. To get the greatest distance between m and x, we need to maximize the m value, get the biggest m value, and subtract it from the smallest x value. You can see that the difference between 25 and 7.5 is going to be much bigger than the difference between 15 and 8.5 or any other combination. So these are the three values we want. So therefore, we can say the lower bound of p is going to equal, so the lower bound, so the a value is going to be 4.55 over m minus x, so 25 minus 7.5. Yeah, and then in our calculator, if you put in, you should get 0.26. Yeah, I think that's it. So the histogram shows information about the numbers of minutes some people waited to be served at a post office. Okay, so we have a couple information. We got the class widths, which is represented by number of minutes. We have a frequency density, in other words, the height. So if you multiply these two values, you get the total frequency, i.e. the number of people. Or in this case, yep, the number of people. Now it wants us to work out an estimate for the proportion of these people who waited longer than 20 minutes to be served. Now, notice how to use the word proportion and not number. So we need to make sure our answer is going to be like a decimal or a fraction or percentage of the amount. So what you could do is firstly work out the area of every single block. That's the easiest way to do it. So let's have a look. So if we look at this carefully, so this goes up to 5, 10, and so on. So for instance, this block here, 10 to 15, it has a class width of 5 and it has a vertical height of, what is it? It's going up in 0.1s, yeah? So it's going to be 2.2. So 5 times 2.2. And that'll give us 11. So that's what you just want to do. Work at the area every block. So this block here has a class width of 5 and a height of 3.4. So it'll be 5 times 3.4, which is 17. And the next one here, so let's do it for each one. Yeah, I'm going to do this quick. This block here is going to be, what's that? So you got 10 blocks, so it's going up in 0.5s. So 0.5, 1. So this has a class width of 2 and this has a class width of 3. So this would be 2 times 2.5, which is 5. So this is 2 times 2.5, which is 5. This one here is 3 times 4, thankfully, a whole number, which is 12. So that's how many people we got here. And then on this long block, which is easy, this is a class width of 15. The difference is 15. 15 times 1, so 15. So that's easy. Now we need to work out an estimate for the proportion of these people who wait longer than 20 minutes. So longer than 20 minutes is from here. We're talking about this across. So we know that the number of people who wait longer than 20 minutes were, let's see, we've got 10 by 1. So we've got 10 people. Now it's going to be 10 people out of the total population. So we need to add up all of these numbers. So it's going to be 5 plus 12 plus 17 plus 11 and plus 15. It's going to be 60. So 10 out of 60. In other words, 1 out of 6. Yeah, that's it. So we got A, B, C, and D are points on a circle. So we got a 4-sided shape enclosed in a circle, yeah? P, C, Q is a tangent to a circle. So we got a straight line. And tangent means it's a line that touches a circle or a curve anywhere at exactly 1 point. So this is the 1 point it's talking about. Okay. AB equals CB. So the lengths of AB is identical, hence the lines here. and BCQ equals x, so this angle here is x. Prove that the angle at CDA, so CDA, so that's why I labeled it D. We need to show that this angle D equals 2x. Give reasons for each stage in your working. Okay, so a few things you have to notice here, yeah? When you have a shape, when you have a four-sided shape enclosed in a circle and it has to touch every point, we can say that the opposite pairs of angle must add up to, so let's say A and C, must sum up to 180. Okay? By the way, this is known as a cyclic quadrilateral because it fits within the circle. Quadrilateral. Is that how you spell it? Anyway, that means A and C must add 180, and therefore D and this angle, let's call it B, must also add up to 180. Okay, so that's one thing. So another theorem which is also important to know is the alternate angle theorem. I'm going to write it down. They say that the angle between a tangent and a chord, which is here by the way, this is the chord, is equal to the angle on the other side of the chord. So, but this only occurs if it's a triangle. So you have to imagine splitting this up into a triangle. So then you're going to say this angle here equals part of the angle D here. So let's call this, let's split this angle D into two bits, yeah? Let's call this one D1 and D2. We can say that X equals D1. So let's replace this D1 now with X. So that's what it means right there. And we can call this angle here D minus X, because D minus X plus X gives you the full D. Yeah. Okay. So that's called the alternate segment theorem. Okay, so if you want to write an equation, you can say angle, so that's angle X. Angle X equals angle, what was that? CDB, yeah? Okay, so that's good so far. And another thing is, remember, we said angle on the other side of the chord, right? So another side of the chord could have been if the chord was here. If the chord was here, this means on the other side's angle would appear over here, so part of A. So then this would also be equal to X. So that's another angle. So we can say that angle X can also equal, what's it, CAB. Angle CAB. So that's another one, CAB. Okay, so it looks like we have a bunch of triangles now, don't we? Now, the importance of having an angle X here is because if you look at this triangle, we can see it's isosceles because you've got a line marked there and a line marked here. An isosceles triangle means two angles and lengths are the same. So this angle must also be X because it's pretty much the same. So we've got X here. And now finally, this is kind of a cool trick. Now, if you take the collective total of this angle here, X plus X, this would equal 2x. So pretty much angle, let's say AC to Q, angle AC to Q is now equal to 2x. And using the alternate segment theorem again, on the other side of this massive triangle, so if you just cut out this line for a second, yeah, let's call this back to D again, yeah, you can see on the other side of this angle here, this is going to lead up to over here. This must also be 2x, because remember, if this is 2x, according to the theorem, the other side is also 2x, and it's proven. So this means angle, what's it called, CDA equals 2x, and we proved it. Okay, number 21. So line L has equation 4y minus 6x equals 33. Line M goes through two different points, and this line L is perpendicular to line M. Okay, so in order to find out if lines are perpendicular, it's very important if we rewrite the equations in the usual y equals mx plus c form. Okay, so this is pretty much fundamental, yeah? Now, for the first line, we can rewrite that. And to rewrite it nicely, you can firstly plus 6x across and then divide the equation by 4. So you get something like 4 equals 6x over 4 plus 33 over 4. And this equation can now be simplified to y equals 3 over 2x plus 33 over 4. So we're not too concerned about the constant, yeah? We're concerned about the gradient m, 3 over 2. So we know that these two lines are perpendicular. That means the gradient, which was 3 over 2 for line L. And so the gradient for m is going to be the negative reciprocal of L. So it'll be minus 2 over 3. In other words, you flip it upside down and change the sign to minus for line M. Okay, so now we have this information. We can use a new y equals mx plus c line and replace our new information. So we've got m equals minus 2 over 3 x plus c. So now we just have to work out what the value c is. And to do that, we go back to our line M and see what points it cuts through. So apparently a line at point A cuts through 5 and 6 when x is 5 and y is 6. So replace your x and y's with 5 and 6. So we're going to have 6 equals minus 2 over 3 times 5, which is minus 10 over 3 plus c. And now we can solve the value of c, which is going to be 6 plus 10 over 3. And in your calculator, you get 28 over 3. So that's perfect. So therefore, our equation on line is now y equals minus 2 over 3 x plus 28 over 3. This helps, guys, yeah? It's always good to do it like this. And now finally, we want to find the value k. K is located at point B. So now let's replace the coordinates into that new equation. So when x is minus 4, y is k. So it's going to be k equals minus 4. So it'll be minus 2/3 times minus 4, which is plus 8/3 plus 28 over 3. And adding those two values up, you're going to simply get k equals 12. And that's it. Okay, question 22. So the diagram shows a cone. So here's our cone. And by the way, guys, you're actually given some formulas for cones in the front of this booklet, yeah? Let's see what they want. So AB is the diameter of the cone, which is over here. V is the vertex of the cone, so the point at the top. Given that the area of the base of the cone in proportion to the total surface area of the cone is 3 to 8, work out the size of the angle AVB. So this angle up here. Let's call this angle X, yeah? Okay, ooh, give your answer correct to 1 dp. This one looks a bit frightening, I'm not gonna lie. So let's have a look at this carefully. So first things first, let's answer what they want. They want the area of the base of the cone, yeah? So we're talking about this area of a circle. So the area of the circle here is literally pi r squared. Okay, so we'll leave it at that, pi r squared. Okay, so for the total surface area of the cone, it comes under two parts. Firstly, it's actually the area of the base plus the curved surface area. And the curved surface area is actually in the front, which is pi rl. Okay, now L is actually the diagonal length here. So we can call this diagonal length L, yeah? So that's one formula. Radius from here to here, yeah? So far so good. Okay, so now filling out this information, so we got everything labeled. We can say that the area of the base of the cone now is, of course, pi r squared to the total surface area, which is going to be pi r l plus pi r squared. So it'll be pi, and actually we can factorize this. You can factorize pi r on both of them. So pi r, and then you'll be left with r plus l. Okay, so looks okay. Now apparently this is equivalent to 3 parts and this is equivalent to 8 parts, right? Now a good thing about ratio is that you can literally treat the parts as total bits. So we know altogether that there's going to be 11 parts, right? And we can say, alright, we know that 3 out of 11 parts is represented by pi r squared over all of these combined, yeah? So it'll be pi r squared over pi r squared plus pi r plus l. In other words, this over everything is going to equal 3 out of everything, 3 out of 11. What we could do is just literally multiply the denominators across to clear them out. So we're going to have 11 times pi r squared equals 3 times these lot at the bottom. So pi r squared plus 3 times, and oh yeah, we're going to expand this as well. 3 times pi r squared plus 3 times pi r l. So I basically expanded this and multiplied it by 3, yeah? Okay. And then let's have a look. Let's collect like terms, yeah? So we're going to have, actually, you know what you can do? You can actually cancel all the pi's. Let me just change the color of the pen. So the pi's go. Actually, they all go. And then you can cancel 1 power of r. So this goes, this becomes 1, 1, 1. So now you got 11r equals 3r plus 3r, which is 6r plus 3l. And you can actually make an expression for L. So you can subtract 6r, so you got 5r equals 3l. And therefore, dividing by 3, L equals 5r over 3, or 5/3 of r. Now, why did I do this? Well, since we're trying to find this angle here, a clever technique is to actually realize that this is in the shape of a triangle. So let's redraw this at the bottom, yeah, so you can see more clearly. I admit it is quite tricky. If we slice this in the middle, we have a right angle triangle, a length of r and a length of L. But we know what L is now. It's 5 over 3r. So 5 over 3r. Okay, that just looks terrible. And we're trying to find the total angle, but let's just call this angle y for now, yeah? So we split in the middle, so when you work out y, you can double it to get x. So to get this angle, notice how this is a right angle triangle, so we can use SOHCAHTOA. It's actually really hard, this question. So SOHCAHTOA, and we just use the relevant sides. Because this is an angle of interest, y, this means the opposite angle y will be O, so this is the opposite, and this is going to be the hypotenuse. So we need something that has O and H, and the only thing that satisfies it is a so not ka or toa. So it's going to be sine of the angle y equals opposite r over 5/3 of r. And you're going to notice a trick here, that the r's actually cancel out. So you're left with, and if you cancel out, you got 1. So you'll be left with sine y equals 1 over 5/3. Now all you want to do is literally sine inverse this. So sine inverse, yeah, don't bother simplifying that, yeah? 1 over 5/3. So sine inverse 1 over 5 divided by 3. You're going to get something like 0.8 dot dot dot. And because y is only half the angle of the total, remember you want x, which is double. You're going to times your answer in your calculator by 2. So times 2. And you're going to get an angle of 73.7 degrees. And I believe this is the answer, I hope. And here we go, guys, the final question. Let's do this. So ABCD is a trapezium. Okay, actually it's probably best to draw this out. It's always good to draw this out, so I don't know which side. Now it says that the direction from D to C equals 3 times the direction from A to B. So there's a good chance that this is probably, let's see, this is probably A to B and this is D to C, because apparently DC is 3 times bigger than AB. So to make it more clear, it's better to put this A, B, and DC. Yep. Now, apparently if you go from 2 to A, which is here, you get this vector, minus 2, 3. If you go from D to B, so all the way across, you go from minus 1 to 7. So it wants us to find the exact magnitude of BC. Well, to get BC, let's have a look. The trick is to travel any possible route until you get to C from B. So what we could initially do is go from B to D and then figure out what D to C is. So let's do that. So we can say that B to C is like going from B to D, then from D to C. Now to work out B to D, well, we actually have it. B to D is the reverse of D to B. So it'll be positive 1 and minus 7. Now DC we don't have. However, to work out DC, we can actually work out AB and then multiply by 3. So let's work out A to B, yeah? So it's all about direction. To go from A to B, we can go from A to D and then D to B. So this would be traveling from A to D plus D to B. And we can do this quite straightforwardly. A to D is the reverse of D to A. So it would be, instead of minus 2, it would be positive 2 and negative 3 plus, and D to B is minus 1 and 7. Minus 1, 7. And then simplifying that, when you come to vectors, you just add across. So 2 plus minus 1 will become 1. Minus 3 as 7 is 4. So we found A to B. And of course, we know from the very beginning, D to C is 3 times that value. So D to C is 3 times 1, 4, which is 312. Easy, yeah? 312. So now we know what this is. So it'll be 1 to minus 7 plus 312. Tidying this up, adding across, you're going to get 4. Minus 7 at 12 is 5. And now lastly, this is the end bit. Find the exact magnitude. The exact magnitude means is you literally use Pythagoras. And by the way, these two bars means the magnitude. So find the magnitude of 4, 5. It's literally 4 squared plus 5 squared square root. And we're done. We're actually done. Put this in your calculator and you'll get root. And this is the exact magnitude. Make sure you do not round it up or you actually drop a mark. And yeah guys, I think we're done.